Hello everybody, welcome to this brief video on OpenHAB2, MQTT and ESP8266-12E project. What we're very briefly going to cover today is the ESP8266-12E for IoT with OpenHAB2 and MQTT using Arduino, and how to install the OpenHAB2 Beta 2.0 and MQTT 1342 on Raspberry Pi 2 and 3. This video will show you what the end result or outcome of this product is. Okay. This might be a little confusing for some, but to briefly explain the relevant screens, over here we have the Arduino 1.6.4 integrated development interface, and here is the code which connects the ESP8266 to our wireless MQTT broker service. Over here we have a serial monitor which is monitoring the activity on the ESP8266 chip. Over here we have the OpenHAB2 basic user interface to the items and custom sitemap created representing each of the GPIOs on the ESP8266 chip. Here we are going to take the events log and we are going to continuously show the last entries into the event log. Over here we have MQTT Spy, and it is basically monitoring all the topics on the MQTT broker service. Over here we have a Raspberry Pi 3 Model B with the wireless enabled power and connected to the network. On it we have OpenHAB2 Beta 2.0.0, and we also have the MQTT or message queuing telemetry broker service or server enabled. Here we have an Android device connected to the OpenHAB service. Here we have an iOS device connected to the OpenHAB service. Over here we have the ESP8266-12E. It's currently off. Power would be supplied to it via a USB cable. We have a serial connection for which over here on the screen is being monitored via the Arduino interface. Alright, so let's just open up a additional session, SSH session we have here connected to our Raspberry Pi 3. Let's just take a look at the network config. The physical network is connected to 192.168.2.80. The wireless network is connected to 10.0.0.1. Alright, I'm going to power up the ESP8266-12E. And if you see on the screen over here, it should be connecting to our, let's just reset that. It should now be connecting to our OpenHAB wirelessly. As you can see, it's connected and it's received an IP address of 10.0.0.5. 10.0.0.5. Let's ping the wireless ESP8266E from the OpenHAB. As you can see, I'm getting a reply, which means I'm now connected. Alright. Basically the process is as follows. If any of the interfaces to OpenHAB, whether it be the web interface, whether it be a iOS app, whether it be the Android app, switches on a GPIO, it publishes a topic on to the relevant GPIO number on the MQTT queue. The chip in turn picks up the instruction, as you can see here, and it switches the relevant LED on. So you can see over here we have that LED has just switched on. In addition to that, you can see that the on button for the iOS device and the on button for the Android device have both switched on. I'm now going to proceed to switch one on the Android device, the iOS device, and you can see it's switched on the graphic and the web user interface. I will switch the next one on using the Android device. As you can see, the buttons are stateful between all the interfaces, so let me proceed to switch them all on using the web user interface. Alright, so here we can see that all of them have switched on. All the buttons here are on, all the buttons are lit, all the on commands have been received, the event log and OpenHAB is reflected, each one as they've switched on, and as you can see all of the LEDs have switched on. Alright, let's proceed to switch it all off. I'll switch off half of them using the iOS device. I'll switch off another two using the Android device, and I'll switch off the last two using the web user interface. Alright, so we've registered all the off events on the ESP8266 chip serial interface. All the LEDs, as you can see, are now switched off. And as you can see, the ESP00 device ID, which is programmed into the ESP8266 chip, is registered with the MQTT service, and it is stable and hasn't dropped off. Alright, these LEDs represent real life analog scenarios where devices need to be switched on and off. Now IoT will produce a product called Genesis. A number of products are going to emerge that will interface with this product set and be able to be ordered online. The project also includes the EagleCAD circuitry for this particular setup. LEDs and breadboards can be purchased independently, and it can be built on a different platform. Alright, coming back to the product, as you can see, the 12E IoT and OpenHAB2 MQTT addresses the ESP8266 chips, circuit board and the serial interface, and the OpenHAB and MQTT portion deals with the Raspberry Pi 3 Model B. The image can run on a Raspberry Pi 2. However, if you plug in a wireless dongle, that would have to be enabled, as opposed to the onboard wireless which is present on the Raspberry Pi 3. Hi everybody, here's just a supplementary video giving a clearer demonstration of the LEDs, which might not have been too visible in the previous video. So please keep an eye on the Android app, which is connected to OpenHAB. ESP8266-12E chip, its LEDs will come on and off as I switch it on and off with the browser interface. Alright, so let's get started. LED 1, LED 2, LED 3, LED 4, LED 5, LED 6, LED 7, LED 8. Okay, let's see if we can switch them off using the Android. Off, 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 off. Okay, thank you everybody for watching.